Hey, what's up, guys? Chung here. Uh, Today let's talk about another LeetCode problem. 120 triangles. So you're given like a triangle, and you need to find the minimum path from top to bottom. And each step, you can only move to the adjacent rows below it. So what does the adjacent numbers below on the row below? What does that mean? So let's say, for example, number 5, right? It can only move to I and 8. For 3, only 6 or 5. For 4, only for 7, 8 to 3, right? So what does it mean? It means that with current index I, right? It can only move to so the next level will be I and I plus 1, right? The index on the next row. So those are the only two options he can move to. So in order to find the minimum path of this, so how can we do it, right? And if we if we do it top down, right? If we do it top down, so we have to keep track of basically each of the possible path, basically, right? We have to try all the possibilities, right? And then in the end, we just return the minimum path, right? That's gonna be a little bit trivial, right? Because every time we have to try this, all the paths, basically. I think a better way of doing it is we do it bottom up, right? That's a better way. For bottom up, right? uh, we're starting from the last. No, we're starting from the second and last of the from the bottom. Basically, for each of the I here, we always pick the smaller uh from this like element adjacent numbers, right? And then we just keep going up until we reach the top one. Then the top one will be our final result. So I think obviously it's gonna be a DP problem, right? Let's do this. Let's define a height first. Height gonna be a length of triangle, right? Triangle, triangle, not triangle, triangle. And then for DP, let's define a 2D DP for now, right? So the DP means the smaller. So basically we define like each element, right? For each element, we define like a number, right? And for each row, each row in this DP will be the level on this triangle, and the inside will also define like a number for each of the element in that row. So at the beginning, everything is like 0, right? And then at this at this i's height, right? Uh, Basically the length is gonna be the length of the row, right? And then for what? For row in triangle, right? So that's how we define this 2D DP. Basically, we just define like a simple array, 2D array with position for each of the element of in the triangle here, right? And then what? And we start from bottom, but we know from the bottom, right? The last DP minus 1, right? The minus 1 is equals to what? It's the same as the triangle, right? It's the same as the triangle, basically. Because for each of the element, for every element on the last levels, the the distance, basically the path to this current value will be itself, right? Because that's the first step. And then we do a for I in range, right? What we do a height, right? Height minus 2, minus 1, minus 1, right? Basically, we'll loop from this one, from the last one from the bottom. Then for j, right? For j in range, for each of the element, of the current level, right? What's the level? That's gonna be the length of dp. We can either use dp or triangle. It doesn't matter because dp and triangle they have the same structure. I'm gonna use the dp in this case. dp what? dpi, right? So that's the current element on current row, and the dp ij, right, equals to what? Equals to the minimum, right? The minimum from the previous one, right? That's going to be dp what? I minus 1, I plus 1, right? That's the height to j, and we get the lesser one from the previous adjacent numbers, right? dp I plus 1 plus j until j plus 1, right? And then which in the end, which at the current triangle, right? That's the current number of that, right? We just do it over until in the end, which will simply return dp 0 and 0, right? That's gonna be our result, because at the first level there will be only one, and this one will be our final result. That should do it. Yeah, cool. See, it's pretty straightforward. And I think one of the bonus point or follow-up question is that if you can use like ON here, right? Because right now, what is the space complexity here? That's n log n, right? That's the total number in this where n is the total number of the rows of in the triangle. I'm not sure if we can do this, but one of the improvements we can do it here is instead of using a 2D array, right? We can only use like, yeah, I think that's yeah, we can do it with O, and n is the height, right? How we can do it, right? Because all we need is the space of the last row here, right? Because once this number is calculated, we don't need the previous level uh, numbers. We can just keep using the same level over and over, right? So we just simply do this, right? We just instead of defining create a 2D array, we just simply initialize this array with the last row, right? And same thing, and here. So here we're gonna have the triangle here, right? Then dp I here. Hmm. So with that, we just need the dpi. That's the level, and that's the triangle of the level. So dpi, yes, dpi equals to dpi plus I plus 1j. Let's see. So it's gonna be dp, yeah, j, right? dpj plus and dpj plus 1. Basically, we're just reusing the previous numbers, and then in the end, we just return dpi 0, right? I think that should also work. dp, oh, yeah. sorry. So yeah, so that's gonna be dp of that. Yeah, so this will reduce the time complexity from n. I think what's the total number in the triangle here? N log n to n, because we're just simply using one reuse the previous like dp result, right? We're just updating, keep updating from the previous result and the current result. The So before assigning this one, this is the last level's result, right? And then we just for the current one, we just reuse the previous level's result, and then basic same structure, but we just reuse the same DP array here. And in the end, we just same just return the first element. That will give us the final result. And yeah, I think that's it for this problem. Yeah, thank you so much for watching the video. All right, I'll be seeing you guys soon. Bye.